Merry Christmas! Mitchell from Australia is a flat earther from Australia, obviously, and we've got a little bit of history.
So does anyone still believe that this image is real? Well, the lies don't stop there from Sideman Dan, because look down the left-hand corner. There's even plane trails.
Plane trails, good one. Those are satellite flares, Mitchell. And why would they be on that photo, Mitchell? Ah yes, because satellites are real and space isn't fake. Well, today we're going to take another look at Mitchell and his hilarious claim that the globe can't predict eclipses. Hello all and welcome along to a Christmas Eve Flat Earth Friday. My name is Sideman Dan, thank you very much for joining me. As usual with the Christmas episodes, this episode will be donating the first 24 hours of its revenue earned on the video to charity. Last year we sent over £500 to the mental health charity Mind. This year I've chosen a relief fund for the victims of the recent tornadoes in Kentucky. Incredibly bad luck that so many people have lost their homes this close to Christmas. If you are in and around that area or you know people who are, I do hope that things are okay and you're getting back on your feet quickly. Right, back to today's video where before we have a look at Mitchell's eclipse rubbish, we're going to have a look at another one of his videos quickly, which he's calling the Australian Black Swan.
Wow. I'm Mitchell from Australia, and this is the Australian Black Swan.
For those of you who don't know what the original Black Swan is, here's a picture. Originally coined by Nathan Oakley and his crew for being a ball buster, you can clearly see that the refraction is just all over the place. Anyway, Mitchell, please continue.
This footage was filmed from an observer height of 5.5 feet with a Nikon P900.
The flat earth camera of choice.
This is point perpendicular. You can see the lighthouse, and these rocks are just demarcation rocks. This is not the argument. My observer location is here on Collingwood Beach in Jervis Bay on the New South Wales south coast. I was viewing these rocks here near point perpendicular. The distance is 7.8 miles. Now that's not the distance to the horizon. That's just the distance to the bottom of the rocks. And I'm just using the elevation tool here to show that the highest elevation possible is about 5.7 meters above sea level.
So that means your observer height isn't 5.5 feet then, is it? It could be as high as 24 feet if we take that into account.
Enhancing this image, we can see that there is a mirroring layer below this boat. That's not refraction or a mirage, simply just mirroring. And we can see the bottom of those rocks where it touches the water 7.8 miles away. This is just a demarcation point. Here is the horizon far beyond 7.8 miles.
Oh, I don't know, it doesn't look too conclusive to me. However, if we actually take a look at how far away the horizon should be with a viewer height of 24 feet, then we get a value of 6.5 miles. Now that's taking into account standard refraction, and with that mirroring you pointed out there, I don't think we can consider this as standard refraction, do you?
And to put it beyond all doubt that the horizon is far in the distance past those rocks, we're about to see a boat appear from behind those rocks, and the horizon still in the distance beyond that boat.
Again, still not conclusive. There is far too much turbulence going on to say whether or not that is or isn't the horizon.
The horizon is definitely beyond 7.8 miles from my observer point. So let's put this observation through Modus Tollens.
Oh, here we go.
If P, then Q. Not Q, therefore not P. If P, the Earth, is a sphere with radius 3959 miles, then Q, every distance to horizon, must be no more than 1.22 times the square root of the observer's height in feet.
Now, I don't have a problem with that if we lived on a planet with no atmosphere. But the thing is, we do, and that value will always be different depending on what location you're at and the conditions on that day.
Enter the Australian black swan from an observer height of 5.5 feet.
Which we've established isn't correct.
Distance to the horizon can be no more than 1.22 times the square root of 5.5 feet, which equals 2.35 miles. That is where the horizon, the physical Earth curvature, must be on a sphere of a radius 3959 miles from a 5.5 foot observer height.
Okay, but no one ever really sees the physical edge, do they, because of the atmosphere?
And we can clearly see the horizon is far beyond 7.8 miles. So to complete the Modus Tollens, not Q, the horizon is beyond 7.8 miles from a 5.5 foot observer height. Therefore, not P, the Earth is not a sphere with a radius 3959 miles. But if you still believe you're on a globe, maybe it's just a bigger radius, which would be in excess of 29,200 miles.
Okay, so the best you can do, the absolute best you can do, is give potential evidence for a larger Earth. No evidence for it being flat, just that it's bigger than we think it is. Nice one. Moving on, let's have a look at this video from Mitchell about eclipses, shall we?
Wow.
I'm Mitchell from Australia, and this is the May 26th, 2021 total lunar eclipse, as predicted by the globe model. But there's just one problem. There was no total lunar eclipse. This is all anyone saw.
It's not what anybody saw, it's what you saw at that time when you took the image.
A partial lunar eclipse. I live streamed this celestial event, expecting to see a blood red moon, a total lunar eclipse, as predicted by the globe model.
Well, actually, this particular lunar eclipse was about as close as being a not lunar eclipse as you can get. As you can see, the moon passes barely into the umbral part of the Earth's shadow and barely spends any time eclipsed.
But I was sadly disappointed, along with millions of other viewers that night, because we only got a partial lunar eclipse. I checked with timeanddate.com. I was in the right area at the right time, but we didn't get to see the right event. Time and Date still says we got to see a total lunar eclipse. So is this just an anomaly?
Well, if we go back and take a look at your very own video of a time lapse of the eclipse, there is a frame where we get pretty much a total lunar eclipse. And your screen right now shows pretty much exactly what you saw. Obviously in real life it's going to be brighter than an animation, which is why we get that extra glare.
Or a mistake by the globe model prediction? Even NASA got it wrong. This is what they predicted with their scientific visualization studio, which I want to point out there's nothing scientific about.
Right, you just showed NASA's prediction and it looks exactly like your image. The only difference is that NASA's predictor is not illuminated. Your image is, of course.
And this is what NASA actually saw. A partial lunar eclipse. But surely this was just a one-off. Let's skip forward now 2 weeks, June 10th, 2021, to the annular solar eclipse. The ring of fire that so many people had been waiting for.
Now let's take a look at who's going to actually get to see this event on the morning of June 10th. And in particular, those of you that are going to be in the sweet spot for the ring of fire solar eclipse in Canada, Greenland, and Russia. Particularly in parts of Canada, Greenland, and Russia, the eclipse will be a much more impressive show and produce what is called a ring of fire solar eclipse. This specific type of solar eclipse occurs when the moon is just a little bit farther away from the Earth and doesn't quite cover up the entire surface of the sun as it does during a total solar eclipse.
And of course, excellent proof of the globe.
Animation courtesy of NASA's pseudoscientific visualization studio. And you know it's true because a guy in a NASA shirt told you. And let's check this prediction from timeanddate.com. what we call the moon moving across the sun and creating the ring of fire. This is what we should have seen. But what did we actually see? This is from NASA videos, and this is the best they got. A partial solar eclipse. Again, another failed prediction.
Well, where were NASA located when they recorded this video, Mitchell? If you had bothered to read the description in that NASA video, then you would have seen that the stream was courtesy of Luc Boulard at the Royal Astronomical Society of Canada, Sudbury Centre. And where is Sudbury in Canada located? In a position that will only see a partial solar eclipse. Dear oh dear, Mitchell, are we going to get a retraction for that one?
Why do ballers constantly tell us that the globe model is true because it can predict things like the eclipse?
And why do flat earthers never research properly?
This is some more footage here from Ontario, Canada, where they should definitely have seen the ring of fire. But once again, this is all they got. So I'm challenging anyone to produce a picture or footage of the annular solar eclipse, the ring of fire, on 10th of June 2021. Prove me wrong and prove your globe model right, because as it stands, your globe model is broken.
Well, it's not, is it? As we've just proved, Mitchell. Dear oh dear. Why do you like to fail so much? I wonder if Mitchell will retract any of these. I doubt it. But for now, we are done and dusted for another Flat Earth Friday, the Christmas Eve special, no less. Thank you so much for watching. It truly is appreciated. If you enjoyed today's video, please do consider subscribing. And if you really liked it, hit the like button as well. Thank you. Just enough time to once again mention that all of the takings, all of the ad revenue from the first 24 hours of this video will be going to a relief fund for the victims of the Kentucky tornadoes. I've been Simon Dan. Have yourselves a fantastic Christmas day, and I'll see you on the other side when we're going back to the mud floods. See you then.